Vibraforge, a scalable prototyping toolkit for creating spatialized vibrotactile feedback systems. Vibrotactile feedback creates tactile sensations through actuators vibrating on the skin. Driving a single actuator is straightforward. Simply use the PWM output from a microcontroller. While a single microcontroller can drive more actuators, the number is limited by the available PWM outputs, which hinders the system's scalability. To add more actuators, researchers develop multi-layer connections. Microcontrollers send commands via a data bus to custom driver boards, which then control the actuators. However, this indirect control prevents actuators from reproducing complex waveforms like audio signals, limiting the system's expressivity. Thus, previous spatialized vibrotactile systems face a trade-off between scalability and expressivity. They either limit the number of actuators or sacrifice feedback quality, hindering immersive haptic experiences. Introducing Vibrafroge, an open-source toolkit that makes the design of spatialized vibrotactile feedback systems simple and accessible. Vibrafroge uses a novel chain connection method, enabling a single control unit to independently manage up to 128 vibration units without compromising vibration fidelity. Each vibration unit contains an actuator, a custom PCB driver, and 3D printed components. The assembly process is effortless, without any intricate soldering. The unit can be attached to a garment with press fit, allowing for easy reconfiguration. By leveraging chain connections, each vibration unit receives independent serial commands from the control unit, enabling fine-grained control over intensity and frequency. By utilizing high bandwidth and low latency data communication, complex waveforms are split into high frequency and low frequency components during transmission. These components are sent through the chain, allowing the target vibration unit to accurately reproduce the waveform. To demonstrate the potential of the toolkit, we use Vibrafroge to build spatialized vibrotactile systems in 3 case studies. In the first study, we replicated a 24-actuator phonemic tactile display from prior research. The original prototype relied on a desktop audio device and extensive audio amplification hardware. Using Vibrafroge, we simplified the design process, creating a more streamlined and efficient solution. As you can see, assembling the system is straightforward and efficient. By simply attaching the vibration units to the sleeve and connecting the wires, the entire setup is ready to go. The whole process can be finished in 15 minutes. Vibration patterns representing phonemes can be intuitively designed in our GUI editor. The designer composes a new waveform by using templates from the library and assigns the waveform to actuators in the canvas. In the second study, we use Vibrafroge to build an upper-body haptic suit for virtual reality fitness gaming. During the fitness game, the user tries to adjust its body pose to match the shape of the wall. If some body parts are not aligned with the shape, localized vibrotactile feedback will guide the user towards the right position. This helps improve the user's training performance. In the third study, Vibrafroge was used to build a suit for assisting drone teleoperation. Vibrotactile feedback delivers spatial cues about obstacles and their risk levels, improving situational awareness when visual feedback is limited. This allows the operators to perform safer and more intuitive control. Vibrafroge bridges the gap between scalability and expressivity, making the design of spatialized vibrotactile feedback systems simple and accessible. For more details, please refer to the paper.